Hello everyone. Today I'm going to walk through a project I built completely on AWS, a multi-agent inventory intelligence system, and I have learned more about cloud architecture from this project. What happened in this project is basically the system starts when I upload a spreadsheet and it runs on a schedule rule using AWS EventBridge, and it can also be triggered through API call manually. Then everything goes into AWS Step Functions. From there, 5 Lambda-based agents process the data one by one. The first agent reads the CSV and store it in DynamoDB. The second predicts stockouts. The third sets reorder priority. The fourth sends email alerts through SNS or Amazon Simple Notification Service. And the fifth generates the final report and stores it in S3. And I built this system entirely using the AWS free tier. Let's jump in. First of all, notice I'm in the Mumbai AP South 1 region. Every service I am about to show you lives here. I chose the Mumbai region because most AWS free tier services are available here, and it's the closest region to me, which means lower latency and no unexpected errors or cost. Before running the pipeline, I want to quickly explain IAM roles, Identity Access Management, because they are the secure backbone of this project. An IAM role is just a permission profile that allows AWS services to talk to each other securely. For example, Lambda needs permission to read S3. Look at the screen. For this project, I created three main IAM roles. Don't get confused, AWS automatically creates many roles when you use services. The Lambda role gives you permission to my agents, access S3, DynamoDB, and SNS. The step function role lets the workflow run the Lambda agents, and the SageMaker role was used to run the forecasting model safely. Let's go to the Amazon Simple Storage Service, S3. So here are my four S3 buckets. This one, inventory row uploads, is where everything starts. When I drop a file here, the whole pipeline fires automatically according to my scheduled EventBridge rules. As you can see, I have already uploaded a CSV file name testinventory.csv. Just look at the inside of this file. Here's the inventory file I have uploaded. It's just a simple CSV with basic product details, item name, category, quantity, price, SKU, stock keeping unit, and supplier. As you can see, there are healthy stock for some items, like the desk lamp with 120 units and the monitor stand with 55 units. But look at these items. Notebooks, only 3 units left. Pen set, just 2 units. Stapler, only 1 unit remaining. These are the risky items the system should detect automatically. Later we can see how the pipeline work and how figure it out. This is other one. Inventory agent outputs is where the final reports land, and the inventory ML artifacts. This stores the trained machine learning models that I created. And the last one I create is inventory web assets. This is an optional bucket I use for hosting my dashboard website, like a public website. I created three DynamoDB tables to organize the data flow. Inventory item table stores all the product data from the CSV file. Demand forecast table stores the prediction like how many days until each item run out. And inventory reports table keeps the history of every report generated so I can track all past executions. These are my 7 Lambda functions. I originally designed it as 5 agents, but later I split responsibilities further for better separation of concerns and earlier debugging. Then I have the core multi-agent pipeline, ingestion, analytics, optimizer, alerts, and reporting. This is where the actual intelligence happens. These two functions handle incoming events like API requests or S3 object events. They start pipeline. What happened in inventory API trigger function? This Lambda function acts as the API layer of my system. Instead of accessing AWS services directly, I expose 4 REST API endpoints using API gateway. The most important one is run pipeline trigger. This trigger the entire step function workflow, ingestion, analytics, optimization, alerts, and the reporting. Then I have the ingest, which allows external systems to push inventory data into the pipeline. And forecast and the reports are read-only endpoints that expose analytics results and generate reports. Now I want to show you how the pipeline actually starts inside the ingestion agent. This lambda is not called manually. It is automatically triggered when a file is uploaded to S3. We can see the event type as S3 object created put, S3 object removed delete. So this is the code that I set to this function. We can see in here, the event object comes directly from S3. It contains the bucket name and the file key. In here, instead of downloading files, we directly read it from S3 using bot03. So this is just a starting point. I created rest of those lambda functions like this with different perspective. Now instead of going through every lambda function one by one, Let me show you how everything is connected and runs automatically. This is where the real orchestration happens. Step functions is what connects all my agents together. This is the brain of the whole system. Go to the inventory orchestra state machine that I created, and I open execution tab. Then I paste this code to test pipeline. It tells AWS which bucket the file is in and what the file name is. I start execution manually. We can watch every agent running in real time. And now you can see agent 4 and 5 are running in parallel. One is sending email alerts. The other one is generating the final report. Step functions made decision automatically. And now everything is green. That means entire pipeline was finished successfully. Under this graph view, you can see all the events that happen in the pipeline. So after the pipeline finish, the system automatically send me two different emails. The first email is the inventory reorder alert, which tells me exactly which item I need to restock and how urgent they are. It groups products into high and medium priority, so I know what to order immediately and what can wait. The second email is an anomaly alert, which checks for unusual or suspicious inventory data, like extremely low quantities or unexpected values. Let's verify the data actually landed. Go to the DynamoDB, inventory item table, explore items. There we go. Every row from that CSV is now in the database. See the last updated timestamp. One more thing I want to show you. This system can also run automatically using scheduled event. This is my EventBridge rule called Inventory Daily Pipeline. This rule triggers the step functions workflow every day at 8 a.m. Indian Standard Time. You can see the cron expressions here. And AWS even shows the next schedule runtimes. That means every morning the system automatically checks inventory, predicts stockouts, and send alerts without anyone touching the system. This is how a real production inventory system would work. So this is what I wanted to show in this video. Thanks for watching.